exponential growth and decay. Most of you have taken so many science, you probably already have dealt with exponential growth and decay. So those are the type of problems that we're working on. So exponential growth, P of t equals P sub naught, which is your amount at time 0, times e to the kt power, where k is going to be greater than 0. K was less than 0, it would be a decay. K is the exponential growth rate, t is time, P of t is the amount at time t. When they're doubling the amount, P of t equals 2 times P sub naught. And that is what they say, P sub naught, because it's a subscript, the O, times 0. So this one here, they give you the population growth of babies under ideal conditions. A population of rabbits has an exponential growth rate of 11.7% per day. That's a big growth rate. Consider an initial population of 100 rabbits. Find the exponential growth function. Okay, so remember that this is P of t equals P sub naught e to the kt power. So on this one, P sub t, your initial value is 100 rabbits, times e to the k, 11.7, just like the interest, 11.7, you move your decimal over twice, so it is to the 0.117 t power. Graphing the function, since we're starting with 100 and it's only growing, you may want to do a window with your x values, of course starting with 0, since they're asking you up to 2 weeks, go to maybe 15 days. And then your y values, you're starting at 100, so maybe start at 95, and then go off to, since this is a pretty fast growth rate, I would probably go to about 500 or 600, so let's say 600. And when it comes to your scale, like that's on you. Okay, so part C. What will the population be after 7 days? How about after 2 weeks? So we want P of 7. So you put this in the calculator, it would be 100 e to the 0.117 times 7 power. And 2 weeks, because it's measured in days, it would be P of 14 would equal 100 e to the 0.117 times 14. So when we put these into the calculator at 7 days, so P of 7 is going to give us about 226 rabbits. You are not, by the way, going to give me a partial rabbit on this. If it's very, very close to the next number, you can round up, otherwise round down. And at 14 or 2 weeks, the value is going to be around 514 rabbits. Okay, so again, this is just putting this in the calculator and getting values. So find the doubling value. Well, at this time now, we want 2 times, so here's part D. We want 2 times P sub naught, which is going to be 2 times 100. So 200 equals 100 e to the 0.117 t power. Divide by 100, divide by 100, and we get 2 equals e to the 0.117 t power. We need to change this to logarithm since we have base e. It's going to be the natural log of 2 is equal to the exponent of 0.117 t. So keep in mind that this is your base and your exponent. Your base goes with the natural log and your exponent goes to the other side of the equal sign. Divide by 0.117 and we get a t value of 5.924. So we can say it's approximately 6 days. That's how long it takes to, oh, and we knew it was going to be less than 7 because in 7 days we got 226. So not surprising that it was under 7. We should have known it was under 7. So if you did this and you got 13, then you did something wrong. So there you guys go on that one. With 100 rabbits starting, it's going to take less than a week to double the amount of rabbits you have. Okay, let's try another one. Okay, so this one here completes the following table. So they're looking for a doubling time on this. So on the way you would set these up, it would be from the last problem, you would recognize it's going to be 2e to the kt power, wait, 2 equals, sorry, try that one again. 2 equals e to the kt power. And before we put any numbers in, which means we're going to have the natural log of 2 equaling kt. And then depending on if we're looking for the t or the k is what we solve for. So this one we want the t time, so we'll put in k. So this one would be the natural log of 2 over our k value, which is 2.4, so 0.024 will give us our time, t. And we don't have to redo these problems. This is what we're going to use every single time. This one I'm looking for k, so it's going to be the natural log of 2 over my t, which is 63. That's going to give me t. We're going to set them all up, and then we're going to jump on the calculator. This one we're looking for t again, so it's the natural log of 2 over k. So 0.014 equals t. This one here should be k. I was looking back going, something's not right there because we're looking for k. Okay, so this one, natural log of 2, and we're looking for k again, so times 38.5 equals k. Natural log of 2, again, we're looking for t. So we'll divide by k, 0.009. And this one, natural log of 2, again, we're looking for time, so 0.026 equals t. Okay, so again, I've showed everything on the top one. 2 equals e to the kt. We got this equation from the last problem. Convert to natural log, so natural log of 2 base e equals the exponent of kt. But on the very first one, I wanted time, so I divided by my k value. I wanted k, so I divided by my t value, and so on and so forth. You put these in there, then this one is going to be 28.9 years. Yeah, we could have pretty much said 29 years. This one here, our k value is 1.1% per year. Part C is 49.5 years. Part E is 1.8% per year. G is 77 years. And the last one is 26.7 years. So there you go on those. Again, don't redo this over and over and over again unless you want to do it over and over and over again, but there's really no purpose. This is your basic formula if you're looking for doubling your values. Okay, now this one is really outdated considering it's so far ago. DVD videos, the total number of DVD videos produced and shipped in '98 was 0.5 million. In 2004, the total number of units reached 29.01 million. And they're asking you things that's going on a little bit afterwards. Now, this is where I would normally bring up in class the fact that this value would actually be going down now because of digital copies and Blu-rays. Okay, so part A, assume the exponential growth rate model applies, find the value of K and write the function. So they only gave us a few information here, but we can use what we do know. Our original amount is 0.5 million. And 6 years later, so P of 6 is 29.01. And we know T equals 6. The only thing we don't know is our K value. So 29.01 equals 0.5 e to the 6k power. Divide by 0.5, divide by 0.5. We get 58.02 equals e to the 6k. Change it to logarithm, so I've got the natural log of 58.02 equals 6k. Divide by 6, divide by 6, and we get a k value of 0.676, which is actually very, very high. So there's our k value. We just did all the math for it. I do want to point out 0.676 is 67, almost 68%. So it's a huge growth rate. Then it says estimate the number of DVD videos produced and shipped in 2004, 2008, and 2011. So 2005 would be year 7. 2008 would be year 10. And 2011 would be year 13. Okay, so we have 7 equals 0.5 e to the 7 times 0.676, and then you throw it in the calculator. P of 10 equals 0.5 e to the 10 times 676, don't forget the decimal, and P of 13 equals 0.5 e to the 13 times 0.676. Throw these into the calculator. This gives me a value of 56.76 million. This one will give me about 431.1 million. And the last one would give me a value of 3.3 billion. So very large. Now, these would be true values. This is called extrapolation of using old data to estimate what something's going to happen later. But we know the coming out of Blu-rays and digital copies. Now, if they count in DVDs, Blu-rays, and digitals all together, these numbers would probably still be really, really good. Otherwise, they're not going to be very good because, you know, if they're talking just DVDs, most people buy Blu-rays now, or just simply go digital. Okay, so decay is same as before. Watch this one here. There's a negative on your K value now. they say as long as k is greater than 0, that's why they threw a negative k, because if the k is less than 0, then your negative will go away. So it's p sub naught times e to the negative kt power. Everything means the same if you're having the amount. So if you're going for half-life, yeah, it probably makes more sense, half-life. P of t is 1/2 of the original. So, and where before when we had double, it would be 2 equals. Now it would be 1/2 equals. So this is for double, and this is for half-life. Okay, so carbon dating. A mummy is discovered in the pyramid. Khufu in Egypt has lost 46% of its carbon. 14, determine its age. Then they give you the radioactive element carbon-14 has a half-life of 5750 years. Its exponential growth rate, K, is 0.00012. So we're using our function, P of t, whatever t is equal to P sub naught times e to the negative kt power. But we know what k is. We also know what this value is. It's lost 46, which means it's got 54% left. So we don't need a value here. We just know that between the two, 54% is left. So it's just e to the negative 0.00012 t power. Change it to logarithms. The natural log of 54 equals negative 0.00012 t divided by negative 0.00012. Sorry, I forgot my decimal here. It's 54%, but remember you can't write it in percent, so you have to put the decimal in there. Don't forget that. I was looking at this going, oh, I forgot something. So t equals, and I throw this into the calculator, and I'm going to get 5134.8 years. So the mummy is 5,135 years old. Okay. There you guys have it. Okay, number of farms. The number N of farms in the United States has declined continually since 1950. In 1950, there were 5,650,000 farms, and in 2005, so 55 years later, that number had decreased to 2.1 million. We are going to change these into millions. So the first thing they're going to ask us for is the k value and the function. So P sub naught is equal to 5.65 million. P at 55, because that's our time, is 2.1 million. T equals 55. We don't know what k is. So we'll put it into the nice little calculator thing here. So I get not calculated equation, 2.1 equals 5.65 e to the 55k. Divide by 5.65. So we get 2.1 over 5.65 equals e to the 55k. do our natural log thing. So natural log of 2.1 over 5.65 equals 55k. Divide by 55, and we get a k value of negative 0.018. Okay, so that was all the work for part A. It says find the value of k and write the exponential function. So this is going to be p of t equals 5.65 e to the negative 0.018 t power. And this is in millions, so when you answer the questions, make sure you identify this is in millions. So part B, estimate the number of farms in 2009. Well, we started out in 1950. Well, they want 2009 and 2015. So 2009 is going to be 59 years later, and 2015 is going to be 65 years later. So on part B, P of 59 equals 5.65 e to the negative 0.018 times 59 power, which is going to give us approximately 1.95 million farms. And P of 65 equals 5.65 e to the negative 0.018 times 65, which is approximately 1.75 million farms. Okay, and then part C asked, at this decay rate, when will only 1 million farms remain? So we have 1 equals 5.65 e to the negative 0.018 t divided by 5.65. Then we get 1 over 5.65 equals e to the negative 0.018 t power. Take the natural log. So natural log of 1 over 5.65 equals negative 0.018 t divided by negative 0.018. And you get a t value of 96. So it's going to take about 96 years. So if you add that to your 1950, we're talking 2046 at this rate. Now it's possible that the rate has slowed down. So because it's never going to get to 0 because we'll always have to have the food that comes off farms. So the values will never go all the way to 0. Okay, extremely long video. I didn't expect this one to be so long. Okay, this is the last bit, radioactive decay. Okay, and remember I was telling you if you're doing half-life, where double was 2 equals, this one is going to be half equals e to the kt. Remember, k is going to be negative, and every one of these k will be negative. So we got to identify k will be less than 0 because we're talking half-life. So if I put this into natural logs, this will be the natural log of 1/2 equals KT. So now we have this, we can go and figure out any of these. So this one here, we're looking for K, so it's going to be the natural log of 1/2. And since we're looking for K, it's going to be over T, which is 3. Okay, this one we're looking for K as well. Natural log of 1/2 over 22 will give us our K value. Natural log of 1/2 over percent, 0.096 will give us our T value. And the last one, natural log of 1/2 over 0.063 will give us our T value. Now remember, K has to be negative, so we're going to throw a negative under it, throw a negative on it. Has to be negative, that way the time will come out positive, because natural log of 1/2 is a negative value. So we put these into the calculator, and the very first one gives me a rate of 23.1%. So this is 23.1% per minute. Gotta watch your units. On the second one, it gives me a 3.2% per year. The next one is 7 days. And the very, very last one is 11 days. Again, don't forget to mark your units. That's very, very important when you're dealing with units. Okay. And that brings us to the rest. This one pretty much is for exponential growth, and these ones for the most part are exponential decay, but don't quote me on those. Oh, I did not change the homework. These are not the homeworks I wanted. This one is good. This is the one I didn't change. I want 10, 13, actually 10, 13 through 15. So 10, 13 through 15. I forgot to change that before I started the video. So there's what we get. Not just a few problems. So there you go. Good luck.